Hi, everybody. We are going to be working on instructional worksheet number 3 for Unit 6. In this problem, we'll be talking about acceleration and average speed. So we're dealing with acceleration, average speed. Please, with your worksheet, sorry about that, I want you to make sure to use the front side for making some notes, writing down information you find useful, etc. On the back of the sheet, you will be solving some problems. First of all, let's define the term acceleration. Acceleration is how fast you change speed. Or another way to say this is how speed changed in a certain amount of time. So let's look at acceleration. First of all, please notice the units are very strange. The units are meters per second squared. So it's distance over time squared. Very unusual. It's abbreviated by the letter A. And please note that this triangle means change. So the change of speed over the change of time. And we'll be practicing this when we get to the other side. I'll write a triangle. To find the change in speed, we take our final. This means final. Let me get to a much lighter font here if I can. How do I get to my lighter font? Okay. Final minus initial speed. Let me try this one. There we go. Let's try that. See if I can get that one. See if that's any less. Final. Well, it's not very beautiful. Let's go to that. Final speed minus initial speed. Most of the time, you're going to start at time 0. So the time passed is what you're going to be looking at. Now, let's get back to working on this. So if a car is traveling at 60 meters per second for 20 seconds, my S will equal 60 meters, but my delta S equals 60 meters squared. There's no change of speed. There's no acceleration. Right here, we have a few examples. Our first example is for acceleration, which is speeding up. You folks are all very familiar with how we solve problems here. So a plane starts at rest and ends up going 200 miles an hour. So you can see here that my change in speed will be 200 minus 100, and this is down there a little bit further. 200 minus 100 meters per second, which is done right here. So my change in speed will be 200 minus 100, or 200 meters per second. My change in time will be 10 seconds. 200 minus 10 is 20 meters per second squared. Reference this when you have an object speeding up. Our next question is deceleration, which is simply slowing down. Is that going to keep popping up? So deceleration means it will have a negative sign. So we'll be looking for a negative sign for deceleration. We solve it the exact same way. Write down our givens, solve for a change in time or speed, put it into our formulas, and solve. So let's take a look here at average speed. I'm going to blow this part up a little bit. Average speed is our speed equals distance divided by time. Everybody here knows that. Let's take a look at our table right here. I don't know why this is so fat on this one. Sorry about this. Okay, so here we can see that our distance, we walked 4 miles, 0 miles, and 8 miles. So we just take our total, 12 miles, that's right here, and we're dividing it by our total time. So we can see that our average speed for this was 2 miles per hour. I hate it when they write it like this. I would like 2 miles per hour. That's how I like those written. So this is where they stop for lunch, but in the time it takes to get from point A to point B, we take our total distance divided by our total time. Now, we haven't spent much time talking about this, but speed is a scalar quantity. Velocity is a vector quantity. What does that even mean? A scalar has no direction, and a velocity has a direction. Vectors have direction, scalars have no direction. So these are important factoids right here. Scalars have no direction, vectors have direction. Let's examine a couple of these. A person walks 4 meters per second. This is an example of speed because it has no direction. We could also say a person walks 2 miles per hour, meters per second, sorry about that, north. This would be an example of velocity. There is a direction. Now let's talk about, those are speed and velocity. A car driving 60 miles per hour toward Dallas. That'd be a velocity because it has direction. Our car traveling 30 miles per hour would just be a speed. We haven't done forces yet. That's not till next chapter. A 14 Newton force pulls 30-degree left of north. That is clearly a vector quantity. A bolt is pulled by 53 Newton force is scalar. Vectors have both magnitude and direction. And if you've ever seen Despicable Me, you'll know what I'm talking about. Velocity is a vector. The vector has magnitude and direction. Okay, there's everything from our first page. Now let's move up here and start solving our problem. We're going to write S or V here. Remember, S or V, and speed, speed has no direction. And velocity has direction. Okay, so we're first looking at a bicycle goes 25 meters per second toward Main Street. The toward Main Street right here indicates that this is a vector quantity. That would be velocity. A person walks 4, and I don't know if that's meters per hour or miles per hour, it doesn't matter. There's no direction here. This would be an example of speed. A plane flies at 200 meters per second. There is no direction. This would be example of a speed. And a bird flies 100, well, we'll go miles per hour, due south. The due south is a direction. That would mean that would be a vector quantity. For this section, please take a moment and think to yourself and make sure you can self-evaluate. Are you able, given quantities, much like these we've just looked at, to distinguish between vector and scalar amounts by looking for direction? Okay, next. More scalar or vector. Scalar or vector. Remember, vector will have direction. 40 miles per hour toward Dallas. That is an example of a direction. This is a vector. Our second, a 25 Newton. Doesn't matter that you don't know what a Newton is yet, but we know that that pulls on a wagon. There is no directionality. This is scalar. Next, 10 meters up a hill. The up a hill indicates a direction. This is a vector quantity. Last but not least, an acceleration of 12 meters per second squared. This will be a scalar quantity. For this section, please self-evaluate right now. Given numbers and values that we've looked at here in the blue, are you able to distinguish between scalar and vector quantities? For the next part, it would be great if you would pause this video for about maybe 1 minute and see if you can solve these on your own. Put your answers in lightly with a pencil, and then after about a minute, come back and check. Okay, I'm assuming you stopped here. I'm going to do first D. D is distance. This is our easiest one. This one will be 23 meters. I'm going to cross this off so you can see that we're done. M stands for mass. And my mass on this one will be 23 kilograms. Next, let's do T, which will stand for time. FYI, I usually use a lowercase for this one. 23 seconds. Next, let's do speed or velocity, and that will be 23 meters per second. This should have been a 23 here. Go ahead and put that in. I don't know why that came off. Acceleration will be 23 meters per second squared. This one right there, if you're having trouble reading that. And last but not least, newtons, which is abbreviated N. This will be 23 newtons. This is force. This is distance. This is speed or velocity. And this is acceleration. I'll just write that much. Okay, now again, please take a moment to self-evaluate. Given these units, can you match them with the correct entity? Now let's move right here. A person starts running from 2 meters per second to 6 meters per second in 2 seconds. So I have my initial, I'm going to call it speed here. I have my initial speed. I have my final speed. And I have my time. Make sure to write all these variables down. So my initial is 2 meters per second. My second is 6 meters per second. And my time is 2 seconds. The formula we're going to use to find acceleration is change in speed divided by change in time. Let's solve. My acceleration, oops, I don't know why it does that sometimes, will equal, I'm going to take my VF minus VI, so that will be 6 meters per second minus 2 meters per second divided by 2 seconds. My acceleration will equal 4 meters per second divided by 2 seconds. My acceleration will equal 2 meters per second squared. Box your answer, put a cloud around your answer, and make sure you've written every single thing down here, every little item. Okay, let's move on. A plane stops, so that means that my initial speed, I keep putting, I'm going to use V on this time, and my V final, and my time. It says a plane stops. So initially I'm going 250, that's miles per hour. And our final is 0 miles per hour. And our time is 25 seconds. This is a really weird problem. This is actually a little bit harder than I would normally give you. Acceleration will equal our VF minus VI divided by T. In this case, since it's slowing down, remember this will be a negative number. My final velocity is 0 minus 250 meters or miles per hour divided by 25 seconds. This is really a hard one. You've got really weird units on this. I would never give this to you on a test. My answer will be 250 divided by 25, which is 1, 2, 4, 5, 6, 8, 9, 10. This will be negative 10 miles per hour second. See, the hour and the second here is a problem. Both your time units go in the bottom. This is possible, but this one is super weird, super odd. And it's a little beyond what I would normally give you. But you're smart, so I'm not going to worry about it. Okay, next problem. A guy bikes 15 miles in 1 hour, rests for an hour, then he bikes 25, and that should be 25 miles in 2 hours. Let's find our distance total. Oops, let's write all of our distances down first. Our distance 1 is equal 15 miles. Our distance 2 is rest for an hour is 0. And our distance 3 is 25 miles. I'm going to have to move this down a little bit. Our T1 is 1 hour. I'll move this down. Our T2 is 1 hour. And our T3 is 2 hours. So we're going to take for our average speed will equal our distance total divided by our time total. D total divided by T total. Okay, sorry about that. So my distance total will equal 15 miles plus 0 miles plus 25 miles equals, you can add this up yourself, 40 miles. My time total will equal 1 hour plus 1 hour plus 2 hours equals 4 hours. My speed average will equal 40 miles divided by 4 hours will equal 10 miles per hour. Okay, you probably had to write pretty little there, but I believe in you. Next, we're asked to consider a dragster's top acceleration is 60 meters per second squared. So my acceleration is 60 meters per second squared. If it accelerates for 3 seconds, find how fast will it be going. Speed will equal. And I've still got to give you something here that I haven't given you yet. Speed will equal, and where shall I go here? Why can't I make this smaller? I'm going to go up here and I'm going to write down a triangle for you. See how I did that? So acceleration equals the change in speed over time. So if I'm solving for this, it'll equal, if I'm solving for speed, it'll equal acceleration times time. Okay, let's begin. Our acceleration will equal, our speed will equal our acceleration, 60 meters per second squared, times 3 seconds. So my speed will equal 180 meters per second. Okay, last thing here. All the graphs we've done so far have been position over time. Please note that this is speed over time. So this is a speed versus time graph. A speed versus time graph. I don't know why I can't write with this one without making it thinner. Okay, let's try this. Let's try this one. See if I can get this to work. Sorry about this every once in a while. This happens. So we're asked in this one to find acceleration. Remember, acceleration equals, we're going to cheat and go speed divided by time. So we're going to find the acceleration for the above graph, and this will equal the slope. So the 2 points I would like you to use are this point, and let's make it easy and use this point. Remember, to find our slope, you're going to take y2 minus y1 over x2 minus x1. This point right here has as its coordinates 10 seconds and 60 meters per second. This point is 0, 0. This is x2, x1, y2, and y1. Sorry if that's a little squash. You can pause here if you need to. So my acceleration will equal y2 is 60 meters per second minus 0 meters per second. And I have 10 seconds minus 0 seconds. So this will equal, 60 divided by 10, 6 meters per second squared. So take a moment right now. If you need to pause to make sure you have this all down, please do. Please do, not please to. Okay. And the last thing on this, Which graph segments A, B, C, or D represent a constant speed? Now, please note this is a speed versus time. So constant speed will be a straight line. So that will be points A and C. So A right here and C right here are both constant speeds. Deceleration, I'm going to put this, means slowing down, and that will be point B. Acceleration means speeding up, and that will be point D. So make sure you know all of each of these. And then our last part of this is the slope of a position time graph means, and that will be speed. The slope of a speed time graph gives us acceleration. I will make the assumption that this instructional worksheet has been 100% filled out, that you have each and every item. I'm having trouble making this small again. There we go. Getting smaller. This will be filed in your notes section of your binder. So please file this in your notes section and follow your instructor's directions for the next thing you're going to be working on.